Okay, so now that we have our list of stocks in the S&P 500 data frame, we need to actually go get the historical price data for each one of these tickers. And before we do that, let's actually clean this up a little bit. So let's put some comment headers here. So in this section, we import tickers. And then down here, we will call this section import price data. And let's go ahead and load in the readr package, which we're going to need to actually get the historical data. So the first thing we're going to do is we are going to go open up a browser, and we are going to type AAPL, which is the ticker symbol for Apple, historical prices. And then one of the first hits you should get is a Yahoo Finance link. Let's open that up. And here you can see the historical prices of Apple stock. So let's change the time frame, because what they're giving us now is 1 year, but we're probably going to want closer to 10 years. So let's change the starting date back to 10 years ago in 2010. And if we click this download button, what we'll get is a CSV file. So basically we can use this download button, and if you right click it and you hit copy link address, you put it up in your browser, right, you can see this is the link to get this CSV file. And so what we're going to do is we're going to open up our studio window, and we're going to type AAPL read CSV, which is part of that readr package we just imported, and then we're going to paste the link, and if we execute that code, you can now see we have a data frame with Apple's historical price. So what we're basically going to do is we are going to loop through all of the tickers in the S&P 500 data set, and we are going to switch out the ticker within this URL here, and that's going to give us the URL for whatever stock ticker symbol that we plug into the URL. So just to kind of clarify this point, if we actually wanted to get Microsoft, what we would do is we would get rid of the ticker symbol in the URL, and we would put in Microsoft ticker, which is MSFT, and we'll change our variable name also to MSFT. And if we execute that code, now we have Microsoft's historical price data in our session. And so what we're first going to do is we're going to write a for loop for all of the tickers. So that's going to look like for symbol in S&P 500 $ticker. And let's just start out by printing the name of each ticker. So we'll say print symbol. And now if we execute this for loop, that's just printing out all of the tickers into the console. So what we're going to be doing now is looping through and replacing AAPL, which is the ticker symbol in the URL, with this variable symbol. And let's save that in a variable called URL. And what we're going to use is we're going to use the paste 0 function. Paste 0. Okay, and we're going to copy out the first part of the URL, so everything before the ticker. I'm going to put that in quotes. And we're going to use a comma, symbol, comma, and then everything after the symbol. Oops, okay. And we're going to put that in quotes and paste it to the end of this paste statement. And so this is basically our URL builder. So we're taking the front part of this URL, we're splicing in our symbol, and then we're taking in the back part of the URL. And so if we print the URL, we can see print URL, and then if we run our for loop, we should be able to see, right, so we have a unique URL for each corresponding ticker symbol. Okay, so there's going to be a couple of pain points if you were to just try to run this as is, so I'm going to try to address some of those right now. So not all of these symbols in this list are going to be the symbols used in Yahoo Finance. So a couple of these are going to give an error, and you can correct for the error, if you want to go through and figure out which symbols give you an error. But I'm just going to give you one example right now. So that's brk.b. So if we were to try and read this symbol in, let's copy this code, it's going to give us an error. So brk.b, if we execute that, right, so we're going to get a 404 error because this URL with brk.b in the symbol is not a valid URL. So we don't want that in our for loop, because if we get an error in the for loop, it's just going to crash the script and we're not going to get any data. So we need a way to handle it so that it can basically see an error and just skip over it rather than have it crash the code. And so the best way to do that is actually to wrap this in a try function. So now if we execute this, we still get the error, but it actually just throws the error into a variable called brk.b. And so if we were to see what type of variable this is now, right, it's going to say it's a character, right, because it's storing the error in a variable called brk.b. So brk.b, if we send that to the console, right, we can see this error message down here. And now compare that to what happens if we run a successful data grab. So if we say mode APL, we get back a list. So we want to get back lists and not characters. And so what we're going to do is we are going to create a shortened variable called RET. Well, actually, first what we're going to do is let's create a data frame outside of the for loop where we can store all of our data. So we're going to call it returns. And we're going to say as.data.frame. And then inside the arguments, we're going to say matrix, NA, and call equals 8, and nrow equals 0. So if we execute this, now we have a returns data frame, and this is a blank data frame. Oops, nrow should be 0, not 8. So now if we re-execute this, right, we have a blank data frame, so it has 8 columns and 0 rows. And so let's rename the columns in the returns data frame. So we'll use the names function, and we are going to say date, open, high, low, close, adjusted, close, volume, and ticker. So you'll actually notice that the data we're bringing in doesn't have this ticker column, right? But we're going to add that so that we know which line item is corresponding to which stock ticker. So if we execute this, we can now go to our returns, and we can see that we have these new column names and a blank data frame. And it's important that this is outside of your for function, because we're going to import the data, and then we're going to place it in this new returns data frame. And so the way we're going to do that is we're going to create a shortened version of return. So we're going to say RET equals read underscore CSV, and then we're going to read the URL. And so remember, we need to wrap it in this try function first. So try read CSV URL. And then in case we get an error, like in the case of brk.b, we want to test to see if the mode is either character or if it's a list. So we want to exclude anything that comes back as character, and the way we're going to do that is we're going to write an if function. So we're going to say if mode RET does not equal character, then we are going to first we'll fill out the ticker column, So we're going to say RET. So at this point in the for loop, we've just read in the first 7 columns that have the price data. So now we're going to also read in, we're also going to fill out, the ticker column, and we'll say symbol. And then we are going to say rbind, or we're going to say returns, rbind returns RET. And so what this is doing is, so let's start at the top of this for loop. So we're creating a URL with each symbol. So we're looping through the S&P 500 ticker list. And for each symbol, we're creating a unique URL that's going to bring in that data for the given ticker symbol. So we're reading it into a variable called RET. We're checking if that variable is a list or a character. So if it's not a character, we're going to go ahead and we're going to fill out the ticker column with the symbol, and we are going to add the newly created RET variable to the returns data frame. And so if we run this code, that's what we should get. Okay, so now you can see it's running through each of these, and it's adding the data to returns. You're not going to see this till the code fully executes, and this is going to take a couple of minutes to run. So I'm going to fast forward here, and then we'll get into cleaning up this data set a little bit further. Okay, so now that that's done running, you should see that you have your returns data frame is now filled out. So you can see I have over 1 million observations of the variables. If I click on returns, you can see that this data frame is filled out and the ticker is also filled in. So just a few touch-ups to this data frame are left. And the first thing you'll notice is that if you click into the returns data frame, you'll notice that the adjusted close, the name actually got converted back to the original name that was coming from the Yahoo Finance CSV file, where there's a space between adjusted and close. So let's actually fix that by copying this function, placing it down below. And actually, let's use the glimpse function to look at our data set. So let's do glimpse returns. And what glimpse does is it allows you to kind of get a summary of all of the different columns. So you see the columns down here in the rows, and then in the second row you see the type of data it is. A bunch of these came in as characters. So we're going to convert them to we're going to convert them to numeric variables. And actually, I've noticed I misspelled volume here, so let's correct that while we're at it. Volume. Okay. And actually, before we even rename or we convert these columns from character to numeric, we actually aren't even going to need the adjusted close or the volume. So let's get rid of those first. So to do that, I'm going to type returns pipe select, let's say date. Let's select the ticker next. And then we'll say open, high, low, close. Okay, so if we run that, then we look at our data set, and now we've only gotten the selected columns. So now let's convert these couple of columns into numeric columns. So we're going to say returns equals returns pipe mutate, and then we'll say open equals. Remember, when we're inside this mutate function, we use the equals as the assignment operator and not the left arrow as the assignment operator. So that's when we're inside of the mutate function. We're going to say as numeric open. Then I'm going to copy this. I'm going to paste it 4 times. Close. Actually, high is next. So high, high, low, low, close, close. Now let's run this function. Okay, it's saying NAs are coerced. So basically what happened was, right, some of the data sets for the different symbols were pulling in probably NAs or some character identifiers within the within the high-low open and close columns, and so that was converting all of the entire column into a character string. And so we just switched that back, and if you'll notice down here you got a bunch of NAs, so that's because those whatever was causing it to be a string in the first place or a character column in the first place they couldn't convert it to a numeric value, so it's giving you an NA in those instances, and that's perfectly fine. But now let's glimpse our data set, returns. Okay, now you can see these are doubles or numeric variables. Okay, so now let's save this out. Let's save it as, let's add one more column before we save it out. So let's actually get rid of this glimpse function. Let's say returns equal returns, mutate to add a column, and we'll say movement equals if else close is greater than open, we'll say up, and if it's not, we'll say down. So what we're doing here is we are comparing the close and the open columns of our data set, right? So what it's going to do is it's going to go through each row and it's going to compare the close and the open, and if the close is greater than the open, we're going to say that stock went up for the day. If it didn't, if open was greater than close, then we're going to say it went down for the day. And so we're going to put that into a new column called movement. And so if we send that to the console, and if we look at our returns, okay, we can now see that movement. So in this first example of M, we could see that open, right, is lower than close. So the movement was up for the day. And now let's actually save this out. So we're going to say save, we'll say returns, we'll say file equals returns dot r data. So this is a pretty big data frame, so it looks like it's taking a minute. Okay, and if we refresh here, okay, there we can see our returns are there. And let's do one more thing before we end this video. So let's actually turn this data. So right now, if we look at returns, you can see all the values, right, are in columns. But let's get all of these values in one column. So basically what we're going to do is we're going to reshape this data frame so that the high, low, open, and close are in one column, and then the value is in another column. So all of the numeric values are going to be in one column. So that's going to help us for some of the charting that we're going to be doing down the road. So to do that, we are going, let's type returns long equal returns. And we're going to use the gather function, and I'll show you again once we execute this function what exactly is happening. So we'll call it series value, and then we're gonna say minus date, minus ticker, and minus movement. So basically what we're saying is keep intact date, ticker, and movement. So date, ticker, and movement, right? So these are all your non-numeric columns. And then we're gonna collapse the column names, so open, high, low, close, into a column called series. And we're gonna collapse the values, so these actual values, into a column called value. So let's execute that. And if we look at returns long, so now we have, right, basically 4 times what we had in our returns in terms of observations. So we almost have 5 million observations now in this new data set. So that's a pretty large data set. But now you can see we have, right, we have the movement, we have the ticker, we have the date, we have whether it's the open and the value for the open, right? And if we scroll down, we're going to have to scroll down quite a way. But you can see that the series is there for open, high, low, and close. And so let's actually join this data to our original S&P 500 data set. So let's say returns long equal returns long, and we're going to use the left join S&P 500, except for the S&P 500 we're only going to select ticker, name, sector, and industry. And then our next argument is going to be by equals ticker equals ticker. Okay, and so what we're doing here is we're trying to take our data set long, right? And if we actually, let's scroll up here. So if we take our data set, right, we have the ticker symbol, and that corresponds to a ticker symbol that's going to be on our S&P 500 data set. But what we want to do is we want to match the ticker on returns long, and then we want to bring in the columns on the S&P 500 table of name, sector, and industry. So we're going to match up the ticker, and then we are going to bring in these other columns. And so that's what we're doing here. So this first argument is the table that we want to join to returns long, right? So we're starting with S&P 500, we're subsetting down these 4 columns, and then we're joining it by ticker. So let's execute this. And now we see returns long has 8 variables. So now we have the name, sector, and industry alongside of our ticker. And now let's save this data set out. So we'll say save returns long. I'll say file equals returns long .r data. Okay, now if we refresh over here, oh, this is still running, so let's give that a second. It's another pretty massive data frame. Okay, so that's done, and now we can see returns long is saved to our directory. So that's it for this video. Remember to subscribe, remember to comment. If anything I did here was unclear, just ask. Also, remember to go head over to my basic data manipulation in R video. That's where you're going to cover a lot of these things like the left join and the gather that we just did, as well as the piping function, the select function. So a lot of these functions that are coming out of the Dplyr or the Tidyr package, that's where I cover those. So like I said, if you liked it, please subscribe below, and in the next video we're going to go over charting some of this data in ggplot2. Alright, thanks for listening, guys.